The flowchart will be a little bit more complicated than just printing it out, though. You know, we've done stuff with while loops that were put inside of DEF functions, and so it'll look like that. So to recap, part of the exam is going to be based on files. Just know that if you're going to open a file, you use the open command. Just kind of memorize its syntax. If you're going to write to it, you use .write. When you're done with it, you use .close. If you want to read from it, you use .read or .readline. You should strip your data after that to remove white space from it, from the ends. And then again, you close it. When you're opening your file, you specify whether you want it to be an output file with a W or an input file with a read. Also, we had a note here about the difference between a stack and a queue. A stack is where every time you add something to it, and every time you remove something from it, you do that at the same end. Just like you have a stack of plates. It's called last in, first out. So every time I do something, it's going to be on the top. Or you can think of that as being, you know, the end of the thing. So put something on it, put something on it, put something on it. Now I want to start taking things off. Take something off, take something off, take something off. So they come in the opposite order in which you push them. Get rid of that. So if you had a stack, you would append to it every time you want to put something onto it. That's called a push. Let's push 3 things onto it. Stack.append. One more. Stack.append. Now I'm going to change these to things that actually make a sentence. I love programming. So we have 3 pushes. This particular language doesn't actually use the word push, but it does use the word pop. If we want to get those items off, we would do this. So print stack.pop. That's going to print programming. Then we print another stack.pop. That's going to print what? Love. And then one more print stack.pop, and it's going to get the first thing that was put on it, which is the word I. I should have made this something that was an anagram, you know.
So does pop is pop first in, first out? Or?
Pop takes things off the end of the list, just like append puts things on the end of the list. How do you put things on the beginning of the list?
Do you have to specify what, like,
yeah, you do an insert and say you want to do it. So this is, stacks are LIFO, which stands for last in. Everything is done on the same end. So you use appends and pops. Queues. It'd be a real drag if you were sitting there and you sent a huge document to the printer and it was about to get ready to print, but then somebody else sent one and they got to print before yours. If printers were last in, first out, it'd be really annoying. Instead, you want first in, first out. Just like people standing in line to go see a movie. If you had 100 people in line and then they let the people standing in the end come in first, that would be annoying. So that's why you don't use stacks to let people into movies. So queues are first in, first out. FIFO. First in, first out. So the operations are done. Yeah, operations are done on opposite sides. So generally we insert and then pop. Now some textbooks will call the insert into it just the word Q, and then they'll call the word pop DQ. Python didn't use those terms. So anyways, we want to insert three things into a queue. Q.insert John, Q.insert loves, Q.insert donuts. But these aren't good insert commands. I goofed them up. You're supposed to specify the position as well. Insert at position 0, insert at position 0, and insert at position 0. So why are we covering this really? Because it covers the idea of append and insert. And as programmers, I want you to have the idea of last in, first out versus first in, first out. And we didn't really hit that more than one day, so that's why we're doing it again. And then if we pop those things off, print q.pop, and we did that 3 times, it's going to print them in order. It's going to print John loves donuts. So that's the idea between stacks and queues. Now let's go look at the next document we had. We've covered file I/O, we've covered queues, we covered the game GUI, but I really don't like throwing on an exam something that you only covered in the last week before the exam. So we're not going to have anything over the GUI in the exam. What did our in-class assignments cover for Unit 3? Well, we did coding bat, which was just some logic problems. We did files. We did scaling and shifting. If you have a pair of coordinates, scaling versus shifting, and one of them is multiplication of your coordinates and one of them is adding or subtracting values to your coordinates, which one of those is scaling and which one of those is shifting?
Scaling would be the multiplying, just changes the size of whatever
Yeah.
you're modifying.
You're wanting to blow it up or shrink it, you know? You got Mario and he's big on his screen, you want to scale him, you're going to multiply your coordinates. Or you want to shrink him, then you divide them. But if you want to move him around on the screen, you need to subtract or add x and y values. So multiplication of coordinates is known as scaling. And you even do that on graphs. You know, if the highest income in the in your city is $100,000, and then the lowest is 0, then you don't want to make a graph where those numbers go off the top of the screen. You also don't want to make a graph where all the numbers are right at the bottom because you can't distinguish them. Instead, you scale them in such a way that 100,000 is at the top and 0 is at the bottom. Now you may have seen some graphs, and these are incredibly common, that are actually almost deceptive. This isn't going to be on the exam, but this is a point that I want to make. Graph. Let's just find a graph, any graph. Okay, here's a good graph, in my opinion. It starts at 0. But you'll see a lot of graphs that don't start at 0. Why? Because they cover ranges like, the price of fruits started at 25 and it gently crept up, to 40. And so they'll draw the graph so that it starts at 25 and it makes it look steeper. It makes the increase look steeper. And maybe there's a reason for that so that you can distinguish finer, changes in it, but it's also misleading. Because what if you have some kind of crime rate graph? And, the crime rate in your city for violent crime was, 5 people per 1,000 citizens. And in the year 2000, it became 7 people. Well, if you put 5 here and you put 7 here and you show a straight line, it looks like crime is skyrocketing. Whoa! But it's not. It only went from 5% to 7%. So people make misleading graphs, whether intentionally or not. What if this graph, yeah, where'd it go? What if this graph had cut it off so that it started at 200 rather than 0, and we stretched it out, we scaled it so that this was more dramatic? That would make it look like small town teens with cell phones was increasing even faster than it did. So it can be deceptive. Sometimes it has to be done because the graph is measuring something that, you know, if it's only wavering by 1 or 2%, and then you have 100% on your graph, it's going to look like a straight line. And so you have to scale it in such a way. But you use shifting. You know, we're going to move this thing down here. We would want to subtract everything in order to draw it so that we would start drawing, you know, at 0. And then you would use scaling to get it to fill your available graph space if you're doing that, you know, whatever your range is going to be. So that's pretty much the idea of scaling and shifting. You do it, you know, when you're visually representing something, regardless of whether you're just drawing shapes or video game characters or whether you're communicating graphs or whatever. And Excel does this automatically. If you type in some values in Excel and then you highlight those things and you say draw a graph, it, you know, makes a pretty graph. It does all the scaling and the shifting for you. So adding and subtracting of coordinates or values is known as shifting. Am I going to ask you how to modify code to do that? No, but you just need to know what the concepts are. Which one is multiplying and which one is adding or subtracting. I appreciate y'all coming in on the last day because you're going to walk out with a little bit more knowledge than the people who bailed on today. You're going to be 5% better programmers. So then we did coding bat, we did the game GUI, we did file I/O. So really, that's pretty much what it's going to be over, which is not a lot of material, so there's going to be a little bit of a rehash. What is an integer? What is a float? How do you convert a string to a float? How do you convert a string to an integer? How do you add items to a list, which was kind of covered in that stacked stuff, you know, and how you access elements in a list, which is stuff that we covered last time. If you have a list, you know, on the last exam, if you have a list that looks like this, L is equal to, you know, you put some things like this and you put red, orange, Roy G. Biv, yellow, green, the colors of the rainbow, you know. And then you want to print out yellow. What's the number of that one? Using slicing.
2.
Yeah, because this is 0, right? That's 1, so that's 2. So if you print L2, you get yellow. And you know how to do that. If you want to get the length of the list, print the length of the list. That list is 4. Since it's 4, that means you can access elements 0, 1, 2, and 3. How do you get the last one? There's 2 ways. You could use the length and subtract 1, but there's an easier way. And this is a Python trick that doesn't work in a lot of other languages. You want to print out green, what slice would you use to get to there?
L negative. Print
Negative.
L
Negative 1. Right. If you use -1, if you use it negative indexing, it goes backwards. -1 is that, -2 is that, -3 is that, -4 is that. So print your list at element -1, and you get green. How do you append to a list? We already did that. L.append, Roy G, blue is the next one. How do you insert into it? L.insert at position 0, and what's before red? Well, we can't see it, but infrared. So that basically covers lists. One more thing though, if we wanted these two colors, we would use slicing. To use slicing, you specify the first value and you specify one past the last value. So print at the first value, what's the index number of orange?
1.
Yeah. Colon. And then we want 2 items, so you just add 2 to it.
3.
So it would be 3. Now that doesn't mean print orange, yellow, and green. It means print orange and yellow, but stop when you get to green. The easiest way to think about it is you just subtract one of those from the other, and you go, okay, I'm going to start at 1, and the difference between these is 2, so I'm going to start at 1, and I'm going to get 2 items. So that would print orange and yellow. So convert string to an int, we know how to do that. Convert string to a float, ask for input, and then convert to an int or a float, that kind of stuff. Write a program that does file input based from a flowchart. The fact that it's based from a flowchart is going to make parts of it easier. But you'll have to remember to do the flowchart. When you do the flowchart, please put all input and output inside the tilted things, but only input and output goes in the tilted things. Not the INT statements, not the math statements, not the list of pins and stuff like that. But, so what goes in rhombuses? Your print statement, your input statement, your file read line, your file write. Those are really the only things that are going to be in the flowchart. Well, I guess file open and file close. I'm kind of ambivalent on that. But absolutely, these 2 things. Nothing else should be in a tilted rectangle. Flowchart of a loop versus a flowchart of an if. That's pretty much it. I've psyched you up. Now everybody wants to take it. Maybe not. Do so if you made 80s on your prior exams and you want to try for a 90 on this one, But send me a note. I sent everybody email right saying, asking whether you were going to take it or not. Did y'all get that? Y'all are looking. Okay, I see some nodding heads. Okay. Just send me an email saying you're going to be here so I don't worry. So I don't wonder, All right, gang, y'all are good students. I'm pretty much happy with everybody's progress in the class, Hardly anybody's making below a C. So, good job, y'all. And I hope to see a lot of y'all in future classes, Java, scripting, or C++, because y'all have the aptitude to do that, and you will relearn the concepts with a language that is more used in the industry, C++, which, games are PlayStation games and Xbox games and Windows applications are written in, and Java, which is done in a lot of network, a lot of network environments. So, see y'all next week on Monday, or see y'all next semester, I hope.